Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. Doing this a little early today because I'm going to be heading up to Raleigh shortly for the Christmas parade tomorrow, and also some other things going on over the weekend. So we're going to be talking about long waves and short waves today, because the upper atmosphere is basically nothing more than a series of waves that move around the northern hemisphere and the southern hemisphere, and there are reasons why those waves are there. So we're going to delve into that and show you some examples today. So let me go on ahead and put myself down here in the corner, and just a few interesting facts. I hope you'll find them interesting about long waves and short waves. Long waves have a wavelength of 3,700 miles to 5,000 miles, and we'll talk more about what a wavelength is in just a second. There are usually about 4 to 5 such waves in evidence around the northern hemisphere and the southern hemisphere at any one given time, but it can range from as little as 3 to as much as 7. Long waves are caused by uneven heating of the Earth's surface and topography. Now, by uneven heating of the Earth's surface, obviously there are land masses that have different shapes, and land heats up more quickly than water does, and so especially in the summertime, you're going to get some pretty big differences between the land and the water. And then you also have topography coming into play, because the air can't go through mountains, obviously, so it has to either go up and over it or around it. And basically what these waves are trying to do is to restore balance between the poles and the equator. They're trying to transport heat northward from the equator and cold air southward from the pole, trying to even out this uneven distribution of heat, but it never finishes the job. And so as a result, these waves continue to develop, and they will continue to develop until the end of time. All right, short waves have wavelengths usually much shorter than 3,700 miles, and these are the waves that actually create our sensible weather from one day to the next. These short waves can help to either amplify or de-amplify long waves, okay? But it's the actual short wave disturbance itself that is creating the sensible weather. And neither long waves or short waves move at the speed of the wind within them. Those winds are simply passing through the wave. So you may have a long wave that's moving eastward at 15 miles per hour, but it can have winds within it of 115 or 120 knots, okay? So the wave is moving at its own speed, and the wind is a totally separate entity, and it is moving through that wave at a much, much quicker pace, okay? But the wave itself is not moving at the speed of the wind within the wave, at least not in most cases. Okay, so here's your basic sine wave, okay, and there are a couple of different ways you can define the wavelength. You can go from the crest to the crest, okay, and so that would be the wavelength between those two, or you could do it between the base here, the trough if you will, and here, okay? So either one of those ways are ways that you can evaluate how long the wavelength is in a given wave. So here's an example, and this is a 500 millibar chart for the entire globe, but instead of looking at the globe as a circle, it's flattened out like this. And so I'm going to show you examples of both of these types of waves. Now, these are long waves, okay, and you can see that at this time there's 4 of those around the northern hemisphere. And these are the waves that have the long wavelengths, like 3,700 miles or greater. But then if you look real closely, you can start to see where the short waves are. Here's one right in here, okay? You see that little dip, but the wavelength only goes from here to here, so it's very short. And then we have another one in here. Now, this may seem a little confusing because you're saying, well, gee, Greg, if these are long wave troughs and these are long wave troughs, then this is a long wave ridge in here, and you're right. And so why am I talking about a short wave in a ridge position? Well, if you notice here, these lines are curved like this anticyclonically, okay? But as you head farther and farther north, those lines become flatter, and if you look really close here, you can see just a little dip in those lines, a little bit of a cyclonic turn. So when a short wave goes over top of a long wave ridge, it tends to flatten it, okay? And then as soon as it goes by, then the ridge recovers and builds back northward again, okay? So short waves don't have to be in a long wave, short wave trough does not have to be in a long wave trough position. It can be in any position it wants to. It's just that when it's associated with a long wave trough, it's going to amplify it, And when it's associated with a long wave ridge, it's going to de-amplify it. And then over in here, you see another short wave in here, and yet another one over in here, okay? And basically, it's between the trough axis and the ridge ahead of the trough where you get upward motion, okay? And if you have enough moisture, that's where you're going to get the clouds and precipitation. And then to the west of the trough, okay, and between the ridge and the trough, this is where you get sinking motion in the atmosphere and the air warms up and dries out. Now, I say that, and you can have very, very cold air coming into the west of a trough. It's just that when the air is sinking, it is warming and drying it. So it makes it a little less cold than it would be without that impact. But you can still have some mighty cold air masses coming in behind these troughs, okay? So that's sort of a wavy example of long waves and short waves in the atmosphere and how they dictate our weather. And of course, if you're a snow lover and a cold weather lover, you want the long wave trough to be just west of a given location, because that way you're able to secure the cold air, but you're also in a region of upward motion, okay? If the long wave trough is east of you, then that's usually bad news, or if it's too far west of you, then you get into the really, really mild air, and that's not a good scenario for snow lovers and cold weather lovers. Okay, folks, that's it for now. That's bonus weather video number 3 for this week. The next bonus video coming up on Monday, and the next daily update coming up later this afternoon. So you all have a good one, and we'll talk to you soon. See you later.